Hello, I am Jay Prakash, lecturer of Computer Science and Engineering Department, Government Polytechnic for Women. Okay, today we are going to do the sixth session on green computing of Unit 2, that is green devices and hardware. So managing the disk input output system. So we've already seen the software plays a very important role in the energy utilization in the computer. So in the IT infrastructures, the energy should be minimized. So how the disk is managed by the supply of data and also outputting the data. The performance of the hard disk drive depends upon the rotational speed. So the hard disk drive depends upon the speed, how the rotation occurs, the speed of the circular disk occurs. The seed time is nothing but the data, the time elapsed in order to fetch the data from one location to the another, rotational latency or delay. The hard disk consumes more energy when it is spinning. So while it is running, it consumes more energy. If the spin time is reduced, energy can be saved. So if the spin time is reduced, obviously our energy can be reduced. Below are the energy usage techniques. So the following are the energy usage techniques. First one, the impact of block size on the sequential reads. So if the block size depends, okay, that depends upon the sequential reads. So how the block size, whether it is less or more. When they're reading a large volume of sequential data, reading the data in large chunks requires low process utilization and less energy. So reading the data in a larger blocks, obviously it will consume less power and obviously it will save the energy. Okay. Next one, impact of native command queuing, NCQ, and random reads. So how the commands or the algorithms which we are used, that will also will affect the utilization of the hard disk. Asynchronous input output with native commanding queue NCQ improves the performance and saves energy. So synchronous input output methods in the command queuing technique also help us to save the energy of the disk. The buffering during the multimedia playback. For multimedia playback, reading ahead and caching the media content will save energy. So buffering means moving the data to the location so that multimedia playback reading and ahead and caching the media content will save energy. It will move the data to the particular location. From that, the data starts reading. That's why it saves the energy. Impact of fragmentation. The performance and energy cost to read a fragmented file are greater than those of contiguous file. So instead of going for contiguous file, we can divide the file into many fragments. So these fragments are taken and it is executed. So it will make the managing the input output in a faster way. The disk input output in multi-threaded code. The performance and energy cost of the multi-threading can be reduced by coordinating access to the shared data. So it means that the energy cost of the multi-threading can be reduced by coordinating to the shared data. If your data is shared in a particular location, that can be used by many people at a time. So accessing the data is very easier. Instead of storing the data to the one computer and it will move to the another server, it takes a many tasks. So if you store the data into one location, that is server, and also multitask or multi-threading techniques can be used so that energy saving can be done. So prefetching and caching. So the three guidelines emerge that can be help save energy during DVD playback are example. Okay, the buffering, applying the buffering techniques which can reduce DVD power consumption by 70%. So move the data whatever be done that will into buffer and overall platform over consumption by about 10. So it will save around 70% of energy. Okay, minimize DVD drive use, reduce DVD spin downs and read access in order to save the energy. So you can reduce the spinning so that will save the energy. Let the OS manage the CPU frequency. So operating system, OS is nothing but operating system. It will manage the CPU frequency. So allow the OS to set the appropriate P state, adjusting the CPU frequency as needed. The power state can be used. So how the CPU frequency can be utilized in a better way. Context awareness. The context awareness in the computer means that they can sense the environment in which they are operating and the software can be designed to react to change in the environment. So depending upon the situation, depending upon the context, we are going to utilize the computer in a better way. Embedded systems are particularly context awareness. So embedded systems are it is an context awareness techniques. Examples of the context aware behavior as follows. As an example has been given here. A PC or smartphone warns you when your battery has reached a low energy state. So the computer, the personal computer, it will wants the battery is at a low energy state. Then we have to recharge. Okay, that is why. So it is an indication that the energy is at low state. A notebook PC responds to the change from AC to DC power by automatically dimming the display. We know that when you switch on the system, obviously a dim will be occurred. So it will tell us that the AC voltage is converted to DC power. A tablet or smartphone responds a ambient light level and adjusts display brightness. So a smartphone will adjust automatically the situation light so that it will be done in a proper way. Awareness of power source. So it is beneficial for the application know its source. For example, if the notebook PC is plugged into the AC power or operating on the battery. So it is tell that it is beneficial for application to know its source. When the power status change, the system should indicate this with a notification. Event notification includes switch from AC to DC power and the battery reaches the threshold. So the indication how the change from AC to DC is also indicative level that is shown. Platform power policies. The micro platform is nothing but the OS. Okay, so Microsoft Windows provides a built-in power policies. So in order to save the policies, the Microsoft has been inbuilt in the features into the operating system itself. Okay, it will help for higher performance, balanced and power saves. They give the user the option to choose whether between the performance and a better battery life. So which one is better, we can select. Application software can use the power policies in the following ways. So which are the application software that can be used? Adjust the application behavior based upon the user's current power policy. So users needs, you can adjust the application behavior. Change the application behavior in response to the change in the power policy. So application behavior can be changed, okay, in response to the change in the power policy rules. Change the power policy to suit the application behavior. So power policy rules can be changed to suit the application behavior. Idle efficiency. What do you mean by idle? The idle power is defined as the power consumed when the system application or the software application and services in the systems are running but not actively executing the workloads. It is nothing but the the system is on but it is not actively participating. So whenever the task has been given, the system starts acting. So from idle, it will switch over to the active states. In this state, there is a minimal background activity. Example, deep sea states residency. One of the key requirements for achieving the ideal efficiency is to keep the system in a deeper sea state. Sea states is nothing but active states. So from idle state, you move the computer to the active states. A duration as possible. So as much as possible, you put in the sea states, nothing but active states. The software should aim to keep the number of sea states transition coming and going out of deep sea states as low as possible. So you have to go switch over to the sea states. Frequent sea states transition from C6 to C7 to C0 are not energy efficient. In C0 is nothing but active duration is very small. The latency to transition in and out of the C states may result in net energy loss. So switching over also makes the energy loss. So the C state should be in the active states. That's because the process should be in the active states always. OS time resolution. So what happens here? The default system-wide time resolution in Windows 15.6 milliseconds, that is the OS receives a clock interrupt from the system time hardware. So the timer resolutions will tell when the clock interrupt fires. The OS interrupt is nothing but another task is been coming while the current executing the program. The OS has to handle the interrupt and leads the energy loss. So the OS decides whether its priority is higher or not, whether to handle that particular task or particular process. Higher resolution timers is used. So evaluating the measure software impact to the platform power. So how the software impact to the platform power. So we can evaluate and measure the software impact to the platform power. First one, computational efficiency. It will help that the better application performs leads to the energy savings. Okay. Data efficiency. It minimizes the data movement and keep track the data close to reduce the unnecessary activity and also saves the energy. Context awareness. Let the system be aware of context and environment which is operating and respond accordingly. Intelligent applications behavior saves energy. So smartphones or smart technology will save the energy. Ideal efficiency. It minimizes unnecessary activities and processor interrupts. So ideal efficiency is there telling that make the task in faster way and whatever the task will come, it will be performed faster. So at the idle, the system is running, but it will waiting for the task. Software tools. The tools are the important assets for tuning the software for performance and energy efficiency. Many software tools can be used. Windows 7 Power Configuration. It's a command line tool that lets the user control their system management setting. So Windows 7 has the many power configuration settings that will save the power. So this will hence the unit to green devices and hardware. Thank you, students.